Cross-account PassRole pattern. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Also, hit the bell icon to get notified of new videos. Cross-account PassRole is one of the most misunderstood aspects of IAM because many people expect to pass roles directly across account boundaries, but that is not how AWS actually works. Understanding the correct cross-account pattern is essential for building secure multi-account architectures. Let's walk through the complete flow step by step using the sequence diagram. The sequence diagram shows 4 participants arranged horizontally. On the far left is user in account A, which represents a developer or administrator operating in account A. Next is Lambda in account A, representing a Lambda function or any AWS service resource created in account A. Third is execution role in account A, which is a local IAM role that exists in account A. On the far right is target role in account B, which is an IAM role that exists in a different AWS account, account B. The flow begins at the top where user in account A creates a Lambda function with an execution role. This is shown by an arrow from user to Lambda labeled create Lambda with execution role. At this point, AWS performs the pass role check. User in account A must have IAM:pass role permission for the execution role in account A. This is the critical point. You never pass a role from account B directly to a Lambda function in account A. You always pass a local role from the same account where the Lambda function is being created. Once the Lambda function is created with its execution role, the next arrow shows Lambda calling the execution role in account A with the label AssumeRole. The execution role in account A is assumed by the Lambda service using its trust policy, which allows lambda.amazonaws.com to assume it. The execution role returns temporary credentials back to Lambda, shown by the dashed arrow labeled Return Credentials for account A. Now comes the cross-account part. The Lambda function, now operating with the permissions of the execution role in account A, needs to access resources in account B. The execution role in account A has been granted AssumeRole permission for the target role in account B. The diagram shows this with an arrow from Lambda to target role in account B, labeled Assume Target Role in account B, using STS. This is a cross-account assume role operation, not a pass role operation. The target role in account B must have a trust policy that allows the execution role from account A to assume it. The trust policy in the target role specifies the ARN of the execution role in account A as a trusted principal. When the assume role request is validated, the target role returns temporary credentials back to Lambda, shown by the dashed arrow labeled Return Credentials for account B. The Lambda function now has 2 sets of credentials, one for account A operations and one for account B operations. Finally, Lambda uses the account B credentials to access resources in account B. The diagram shows this with an arrow from Lambda to target role labeled Access Resources in account B. The target role responds with success, shown by the dashed arrow labeled Success. Throughout this entire flow, PassRole was only used once, at the very beginning when the user in account A passed the local execution role to the Lambda function. All cross-account access happened through AssumeRole, not PassRole. The key takeaway shown in the note at the bottom of the diagram is that PassRole is account local, meaning you pass roles within the same account. Cross-account access is achieved through AssumeRole with proper trust policies. You configure the role in account A to have permissions to assume the role in account B, and you configure the role in account B to trust the role in account A. Now let's examine the 3 code blocks on the slide which show the exact IAM policies needed to implement this cross-account pattern. The first code block shows the pass role policy that the user in account A needs. This is a standard IAM policy statement with effect set to allow, action set to IAM:"pass role," and resource set to ARN:AWS IAM: account number role / lambda execution role. Notice that the account ID represents account A, and the role name is lambda execution role. This policy grants the user permission to pass the lambda execution role to lambda functions when creating them. Without this policy, the user would get a PassRole error when trying to create the lambda function with this execution role. The second code block shows the policy that must be attached to the lambda execution role itself in account A. This is the permission policy that defines what the execution role can do. The statement has effect set to allow, action set to AssumeRole, and resource set to ARN:AWS IAM: account number role / target role. Here the account ID represents account B, which is a different account. This policy statement grants the lambda execution role permission to assume the target role in account B. When the lambda function runs and needs to access account B resources, it will use the AWS AssumeRole API to obtain temporary credentials for the target role. The AssumeRole action is what enables cross-account access. The third code block shows the trust policy that must be configured on the target role in account B. Trust policies are special resource-based policies attached to IAM roles that control who can assume them. This trust policy has version set to 2012-10-17 and contains a statement array. The statement has effect set to allow, principal set to an AWS object with value ARN:AWS IAM: account number role / lambda execution role, and action set to AssumeRole. This trust policy explicitly allows the lambda execution role from account A to assume the target role in account B. The principal field is critical because it specifies the exact ARN of the role in account A that is trusted. Without this trust policy, even though the lambda execution role has AssumeRole permission in its own policy, the AssumeRole call would fail because account B's target role would reject the assumption request. Both sides must agree. The assuming role must have AssumeRole permission, and the target role must have a trust policy allowing that specific principal. Thank you for your attendance. Please consider subscribing to the channel and liking this video.